like with degrees, radians are a unit that can be used to measure angle size. And 1 radian is formed by an arc between two radius lines, and this arc is also the same length as the radius of the circle. So the blue sector here creates an angle which is of size 1 radian, and this radian does have an equivalent value in degrees. And if we have 2 radians, we'd have the following, where to 3 decimal places 2 radians make 114.592 degrees. And we can look at how 1 radian is equal to 57.295 degrees. Here we have a full circle, and we can fit 1, 2, 3, 4, 5, 6 radians inside, which also gives us 6 radius length arcs on the outside, with a little bit extra here which we'll come to. Now the circumference of a circle, which is the length all the way around, can be found by doing 2 multiplied by pi multiplied by the radius. So this tells us that 2 pi radius length arcs make a full circle, and 2 pi is roughly equal to 6.28. So we have 1, 2, 3, 4, 5, 6 radius length arcs, plus this little bit that we had left over, that is the 0.28 of an arc, a radius length arc. And we also have the following, where each arc creates an angle of size 1 radian, label it like so, as we saw over here, and our 6 radians fit inside a full circle plus the 0.28, and it's not just of the arc, it's also of radians, as 2 pi radians make a full rotation around a circle, with 2 pi radians being equal to 360 degrees. So we can label here, for radians we'd start at 0 like with degrees, but the full rotation is 2 pi, and pi radians then subsequently is equal to 180 degrees, that's half of 360. So we can label pi over here, that's the rotation, half circle is pi radians. So we have that pi number of radians is equal to 180 degrees. Now we can divide both sides by pi. Now pi's cancel on this side, so we're left with just 1 radian, which is equal to 180 degrees over pi, and 180 degrees over pi gives us 57.295 for degrees, which shows us that this is our value for 1 radian equivalent in degrees. And we can add a couple more images on the left to show what's going on. So if we have 2 pi radians we have 6.28 radians, which, as we know from over here, gives us all the way around the circle rotation. And if we have pi radians, that's 3.14 radians, which is the same as 180 degrees. Pi radians is 180 in degrees for measuring the size of an angle. Now, for converting from degrees to radians, we'll use 45 degrees in example A to show how we can do so. Now, 45 degrees happens to be a quarter of 180 degrees. Now, 180 degrees, as we know now, is equal to pi radians as a rotation. Thus, a quarter times pi gives us pi over 4. So 45 degrees is pi over 4 radians. So this angle is 45 degrees and also pi over 4 radians. Now, if we take what we have here and divide both sides by 180 degrees, this side becomes 1/4, which is going to be helpful. So this shows that writing the angle we wish to convert from degrees to radians over 180 degrees gives us the fraction we need to multiply pi by to give us the radian value. So if we have an angle in degrees, then the radian value can be found by doing the angle over 180 multiplied by pi. So, for example B, 214 degrees, we have 214 over 180 multiplied by pi. So 214 multiplied by pi, other way of writing it, over 180. And the value of this sum is 2 decimal places is 3.74. So 214 degrees is 3.74 in radians. So the angle is 214 degrees, or you can call it, with radian measure, 3.74 radians. So sometimes a degree to radian conversion turns out to be a nice fraction with pi involved, but sometimes it's better to write it as a numerical value, as we do for example B.